Okay, we're getting started here with our 11.2 day one. We're looking at vectors and continuing on with this Snowpiercer motif. Yeah, if you have done vectors before, especially in something like, I don't know, physics or something, then this should be pretty okay for you. I hate to be the first one teaching some of you vectors, especially when it should have come up by now, but that is what it is, and hopefully we won't make too much of a mess out of this. So let's take a look at vectors. Well, what is a vector? Actually, let's talk about Snowpiercer, because I love Snowpiercer. Here we go. So, all right, so the next logical question about Snowpiercer, once we're able to go ahead and chart the path of the Snowpiercer, is to take a look at velocity and speed. So we're going to be doing that over the next couple of days. On New Year's Day, there's a very memorable scene in the movie where the train is traveling on a path, and we're going to describe that path as northeast. But how can we describe that direction more exactly? What kind of concepts of velocity can get expressed, or how can the concept of velocity get expressed with parametric equations? So when the position is defined parametrically, xt and yt, then x prime, which is the derivative of x with respect to t, and y prime, also with respect to t, become what we call vector components of the velocity. A vector looks a lot like an ordered pair of numbers, except for, well, they have angled brackets instead of rounded brackets, and that indicates that this is a direction and a magnitude of a force and not a location. Okay, vector is not a location. When you graph the initial point of the vector at the origin, then the vector indicates direction. Actually, it doesn't need to even be at the origin. It could be anywhere, and it's going to indicate direction. So let's take a look at these two here. Let's zoom in a little bit. All right. They are two vectors, but they're really the same vector. Notice that over here, this vertical distance, that is how much? From from 2 to 6. That vertical distance is 4. And from here to here, this vertical distance is also 4. This horizontal distance here is 3. And this horizontal distance here is 3. So really these two vectors are both saying the same thing. We're going upwards with a force or a speed of 4, and over to the side with a speed of 3. Both of them are saying the same thing. So both of these vectors are what we would call equivalent. So let's back out a little bit now. We should probably say that oftentimes we're going to call this bottom part of the right over here, we're going to call that the tail, and we'll call that the tip. So tip to tail. Okay. Both vectors are valued at 3, 4. Both vectors indicate the same direction, northeast, and the same strength. The vector doesn't indicate position. It only indicates direction and magnitude. So we can put that vector wherever we want to indicate that speed. Okay, so direction. The reference angle, the angle from the horizontal axis, we'll call that phi, can be obtained with arctangent of y over x, where y is the vertical component and x is a horizontal component. Quadrant information can be used to find theta, the angle formed with the positive x-axis. So basically, you're going to be, adding it from, or if the vector points into the second quadrant, then you're going to be subtracting your reference angle from pi. If it's in the third quadrant, you're going to be adding to pi. And if you're in the fourth quadrant, then you're going to be subtracting it from 2 pi. That's the way reference angles work. So magnitude is the strength of the force. This is less confusing. You just use the Pythagorean formula to figure out how long that vector is, and that's going to tell you how strong the force is. So the bigger the arrow, the stronger the force. So here we go with this vector, -1, 3. Phi, the reference angle, is arctangent of √3 over -1, absolute value of, which tells me that phi is pi over 3. Since we know we're in the second quadrant, we know it's the second quadrant because this x component is negative, this y component is positive. That puts us squarely in the second quadrant. Because all of that's true, we know that theta, the actual angle, you can notice theta here is the angle that's formed with the positive x-axis. That is going to be equal to 2 pi over 3, which is, where is my cursor? That is pi minus phi, which is equal to pi minus pi over 3, or 2 pi over 3. So that's where all of that comes in. Okay, moving on here from this, we'll have the magnitude. The magnitude is just the square root of 1 squared, which is 1, plus the square root of √3 squared, which is 3. 1 plus 3 is equal to 4. Square root of everything, and that's where we get the 2. Okay. We have additional rules about vector addition and scalar multiplication. Let u and v be two vectors. Notice how we have, what is this, u x component, u y component, v x component, v y component. That's probably a bit confusing because we usually use v for velocity. And we'll let k be a real number. In terms of vectors, to differentiate vectors from the kind of numbers we've been using all along, we're going to call the numbers we've been using all along scalars. So scalar is a regular number. Vector is, of course, that 2-coordinate thing that we've had that indicates direction and force. Okay, if you add two vectors, you just add their components, straightforward. If you multiply a vector by a scalar, you just multiply each of the components by that scalar. The opposite of a vector, negative vector, is the opposite of each of their components. And if we're going to subtract two vectors, well, then you're just adding the opposite of a vector. All of those kind of make sense. And then over here, addition of vectors is often thought of in one of these two methods, either A or B. This is what we call head to tail or tip to tail. We go, if we're adding u and v, then we take u and then we take v and we translate it to the tail of u. Sorry, we put the tail of v to the tip of u, and it wherever the tip of v ends up, that's going to be u plus v. There's this other one which I don't really use, but it looks like if you create a parallelogram with u and v, then of course u plus v is the opposite diagonal of that parallelogram. Either way of these is just kind of fine. And that's all we have, really. So let's get our important ideas down on paper here. Okay, so here is our important information. I noticed I misspelled quadrant. Our important information just kind of distilled down to the bare essentials here. We've got concepts of vector addition, vector subtraction, some multiplication, although we're never going to multiply two vectors together in this class. We'll do that in physics, I'm sure. We also have how to find magnitude, just a Pythagorean identity, how to find your direction using Arctan, and then quickly a quick rundown about the quadrant information, how that works. and that should set us up for everything. So pause it here so you can copy it down. I'll make a face so you'll have my stupid face already. 3, 2, 1. Good. Now that you've paused it and copied all that stuff down, we can get to work with the rest of this stuff. All right, there's our important ideas. Number 1, find the magnitude and direction angle. Okay, I'm going to pick up my stylus. Now we're going to get to work on that one. Let's see. The first one is -2, -2 for our vector. Like normal, my stylus is not working very well. Oh no. All right, crisis averted. Here we go with magnitude and direction. First of all, magnitude is going to be equal to, let's just call that the magnitude of v. That's going to be equal to the square root of -2 squared plus -2 squared. So how much is that? The square root of 4 plus 4, which is 8. This is calculus. You don't have to simplify square root of 8. I'm sure your algebra teacher is going to be in shock, but that's 2 square root of 2. And now how about our angle, direction angle? Let's figure out our reference angle first. Phi, that's equal to arctan of -2 over -2, which is equal to the arctan of 1. I noticed that I wrote both of those arctans slightly different. What is the arctangent of 1? Well, that happens when the sine and cosine are equal to each other. Those sines and cosines happen to be equal to each other at pi over 4. Pi over 4, that's our reference angle, pi over 4. Okay, what quadrant are we in? We're in, well, the x component's negative, the y component is negative. That's why we have -2, -2. That means that we're pointing into the, well, if we put the tail of the vector on the origin, our vector would be pointing into the fourth quadrant. Taking a look up over here, in order to get theta now, I just need to do 2 pi minus phi. So theta is equal to 2 pi minus pi over 4, which is equal to, what, 8 pi, so 7 pi over 4 for our direction angle. Okay, easy enough. Let's take a look at this next one. We've got the magnitude of v, is what we're going to call it. That's going to be equal to the square root of 3 squared plus 3 root 3 squared. Oh boy, how much is that? That's a square root of 9 plus the 3 rad 3 squared. That's going to be 9 times 3, which is 27. 9 plus 27, that's 36. Oh, hey, look at that. 36 is a perfect square. That's 4. So we've got the magnitude of v equals 4. Okay. Lastly, for this problem, we're going to get the direction angle. So our direction angle, we get first our reference angle, phi equals arctan. The y-coordinate, -3 root 3 over the x-coordinate, -3. That simplifies into the arctangent of square root of 3. Okay, so let's think about this. When is the arctangent square root of 3? Well, that happens when cosine is square root of 3 over 2. Cosine is square root of 3 over 2 at pi over 6. Okay, so there's our reference angle, pi over 6. Next, we're going to figure out theta. So let's figure out what quadrant we're in. The x-coordinate's positive. The y-coordinate is negative. which indicates that we're in quadrant 2. So taking a look up here, there, we see that quadrant, if you're in quadrant 2, theta is pi minus phi. So my theta is pi minus pi over 6, which is, let's see, that's 6 pi over 6 minus 5 pi over 6. So theta is 5 pi over 6. Okay, that takes care of parts A and B for number 1. Let's see what else we have in sound. Oh, magnitude and direction. Find the vector in component form. Okay, so we didn't talk about this too much. I think I'm going to have to adjust up over at the box. But if we're finding magnitude, if we're finding the vector in component form, well, then the x component, that's just going to be the magnitude 3 root 2 multiplied by the cosine of pi over 4. So that is 3 radical 2. Cosine of pi over 4 is radical 2 over 2. So if you multiply all that together, you get 3 times 2 over 2, which is just 3. The y-coordinate is going to be equal to 3 radical 2, and then now the rate we're going to use sine of pi over 4. Okay, what is sine of pi over 4? Well, that's the same. Rad 2 over 2. Meaning the y-coordinate is also 3. So in component form, this vector is 3, 3. Okay, great. Let's take a look at letter B then. We're going to do the same thing. 2 pi x equals 2 root 3 cosine of 5 pi over 6, which is 2 root 3. See, what's the cosine of 5 pi over 6? That is, let's see, in the second quadrant. Cosine is going to be the longer of the two, so that is negative rad 3 over 2. So x equals negative 3. The y component is going to be similar formula. 2 rad 3 multiplied by the sine of 5 pi over 6. Okay, so that's 2 radical 3, the sine of 5 pi over 6. Well, that's just going to be the pair to negative root 3 over 2, which is 1/2. Again, quadrant information, we're in quadrant 2, so my y-coordinate should be positive. So what does this multiply to make? Well, that just multiplies to make rad 3. So in component form, if my pen, my stylus stays alive long enough, and it doesn't. Okay, and finishing this up then, in component form you have negative 3 and radical 3. There we go in component form. That's it for now. Let's put it up here. I'll get you that extra little bit. Okay, so here we are adjusted. You'll notice the last line at the bottom here. If r is a magnitude and theta is a direction, then xy is just equal to r cosine theta, r sine theta. So that should be it. Hopefully this will be of use to you as you do 11.2 day 1. And I'll see you when I see you. See you, everyone.